Alright, so we got a special update for Crash here. So I had to replace my servo controller that was failing. This is the SSC32 Serial Servo Controller. SSC Serial Servo Controller, 32 channel. I bought this from Linux Motion like 20 years ago, and it was a good unit until it started failing. I went over that in another video about how I broke the Atmega on it. We may try to rebuild this down the road. I don't know. For now, it goes in the junk bin. So originally, I was just going to clone that, and I have this Mega Pro here that I was using to control all the servos, and I got to thinking, okay, and ended up doing this a different way. So now, the way that we've got Crash set up, and the way that we're going to do his arms, I've got a Nano in the hand that controls all the servos in the hand, and those are addressable on a serial port. Now, I've also got another Nano here that I'm going to install in the, hold on, let me fix my light. In the upper arm here, and that's going to control the servos in the arm as well as read sensor data and whatever else I decide to hook up to it. So the way this will work is this serial port will plug into the main processor here, the ESP32, and they daisy chain. So TX from here goes to RX on here, TX from here goes to RX down here, and then TX from here loops all the way back to the 32. And by daisy chaining these down the line, that allows me to address everything in the ARM with one set of commands. Each section runs independently of the other section, and if I need to send data back to the main CPU, then anything that's out of the command range for these two processors, it just forwards it to the next processor in the chain until it loops back. And we'll show some examples of that here. So for example, everything that's addressed on the chips is under the range of 100. So if I put in 100, it echoes back. Or if I put in 105, it echoes back. But if I enter a command to address one of the servos, let's make his armpit move up. How about that? So let's do 3, and then we'll put it at position 95, right? We'll send that command. And he raises his arm up. And it didn't echo that back. Now we can go and we'll stick him back down to 35, which is a relaxed position. Right? Well, almost a relaxed position. Let's go a little farther than that. There we go. So that's neat. Now, that's the upper arm, but what if we want to control the hand? Well, so if we send a command code to this for the hand, you'll see these are single-digit addresses. Those are double-digit addresses. So to do the preset positions, we'll just do, we'll make them point. So we'll do our start bit, and 51 is the point, and then no data, and then the end bit. And when we hit enter, his hand points. Alright? And then we can still go back, and we can make his arm move up. Right, while his hand is pointed. And we'll go further than that. We'll take and go from a point to rock on. Right. And then we'll relax his arm. Oh, excuse me. So, yeah. So now I can address every piece of his arm independently on one serial bus. And we have 3 of those on the ESP, so we'll use one for one arm and maybe one for the other arm. We'll see. Maybe we get away with using one bus for both arms, but the idea is I'm going to have data flowing live to all the stuff on the arm and sensor data coming back, and I want as low latency as I can get with that. And this seems to be the way to do it for as many things as I want to run down the road. I also started playing with some other things. Come to find out, the ESP is a dual-core processor, And there's a way to run simultaneous loops on the ESP using pinning those tasks to each core, because it's a dual core. So we'll be playing with that down the road too, which will be a lot of fun. But that's the update for now. I would draw some more commands to the arm, but I can't enter them very fast while holding my camera phone. So that's just a tease for now, but we'll get some movement and some motions coming up here pretty soon. I've got to completely reprogram all of his movement sequences that we used to have, the dancing and the gestures and grabbing items, everything, because with this one, all of our readings were in microseconds, and we're changing over to angles on these because we're going to be using inverse kinematics here in the future to control where the end effector of the arm ends up in a 3D space. And to do that, we need to write angles to the servos instead of microseconds. So we're using a different servo library now with these in order to accomplish that. And that's another update for down the road too, because I haven't gained much ground with that. But I got done soldering today and figured, well, why not? Let's throw an update up, huh? So, yeah.